only these two graph parabolas, which might surprise you. In particular, this equation, y equals x squared plus 2xy plus 1, does not graph a parabola. Even though there is an x squared term, there's also this term 2xy. Looking back at the general form, we don't see any terms here that have both x and y in them multiplied together. So this does not fit the bill. We'll see this graph in just a second. And of course, you'll recognize this graph as a straight line. This is linear. Think to yourself what the slope is and what the y-coordinate of the y-intercept is. This last answer may also have been a little bit tricky for you. I know that right now this doesn't look at all like this general form equation of a parabola. But if we distributed multiplication by what's in this first set of parentheses to what's in the second one, we get something pretty interesting. In fact, let's look at the graphs for all four of these right now. So here are the graphs for all four of the equations we just looked at. This funny red curve, which has a big break in the middle, is the graph that corresponds to the equation that we've never seen anything like before. Y equals x squared plus 2xy plus 1. How funny that this isn't even in one piece. This is called a hyperbola. We're not really going to deal with them much, but it's important to recognize that having a term like xy makes an equation no longer an equation of a parabola. The solitary straight line is, of course, y equals 5x plus 7. The yellow curve is the parabola y equals 3x squared plus 2x. And this last curve left, this big blue arc, is y equals negative 1/8 x minus 4 times x minus 24. We can see that if we multiplied out all of the terms inside here, we'd end up with a term with an x squared in it as the only term of degree 2. And it does indeed graph a parabola.